So I've modified the equipment just a little bit. I've put a small notch here to raise it up, and I'm just going to check this. So I find that with them in the one position, there's an imbalance. I can't make it balance. If I move it out to the 2, I get a balance. I get the equilibrium. I've just repeated this equation here. 5 times 1 equals 2.5 times 2, 1, 2. So for the good of us all, I will write that in. That's the missing number. Now earlier I told you that in the weight of the system this mop handle hardly matters. It's a very, very tiny amount. So that gives me an advantage of being able to slide the mop handle outwards, and I can still obtain balance. There we go. It's not quite on, so the mop handle does have some influence, but you can see we've reached an equilibrium, so they're now balanced. So I want to look at this second one. If I move this, the 5 pound weight, out 2 units, like this, where does the 2.5 pound weight have to go? Put it here. 2 times 2.5, it gives me 5. My target is 10, so I should double that distance. So 1, 2, 3, 4. So it's just around here. And again, because I'm using this little notch, the balance has become more sensitive. There's less tolerance in the system. So I can go ahead and write down the second number, which is 1, 2, 3, 4. So by experiment, I have proved what I could do in my head. So I could prove that by using paper that I could make a balance out of this system. It was an educated guess. Again, I've got to be watching out. If I slightly increase the weight here, it seesaws, because this side is greater, and then that side is greater, so I can get some interesting behaviour out of this system, but mostly it is in balance. If I push it down too far, maybe it will nudge the weights and it will really go out of balance. But this is very close to the web page information I shared with you about greater than, equals, less than. It's practical. You can even go to the fun fair, the carnival, and have huge laughs. The PNE down in Vancouver. It's all about balance and having thrills, spinning a system so the system can stay in equilibrium and spin around. So imagine that you're out on the end there. Woo! For us old uns, that's a white knuckle ride. For you, you want to do it again and again and again, and I get it. You go ahead and have fun, but the math makes it safe for you to have that kind of fun.